Hello, this is Mrs. Ward, and I'm going to go over the last couple examples for section 10.4, graphs of hyperbolas. So let's get started with example number 3. This one have the 5x squared minus 16y squared plus 64y minus 144. So the first thing I'm going to do is I'm going to have to complete the square at least once. So I'm going to put all my x's together, all my y's together, and anything that doesn't have an x or anything that is a constant, I'm going to put on the other side by itself. So I am going to write 5x squared minus 16y squared plus 64y, and then I'm going to put that 144 over to the other side. So I'm going to add 144 to both sides. The 5x squared, I do not have a linear term, so I cannot complete the square, so I'm just going to leave it as 5x squared. Then the negative 16x squared, whatever my coefficient of the y squared, that's what I have to factor out. So I have to factor out a negative 16, and I'm left with y squared. And because I'm factoring out a negative sign, this positive sign is going to change. It's going to become minus. And then this is 4y. I'm going to put a plus and add some number there. And this is still equal to 144. When I go ahead and complete the square, I am going to take half of 4. And when I take half of 4, I get 2. 2 squared will be 4. So I am going to write minus 16y minus 2 squared. 2 squared is 4. But I'm really not adding 4 to both sides because I have to remember that I have this negative 16 out front. Then I'm actually multiplying by that 4. So this will be a negative 64. If I add negative 64 to the left side, I have to add negative 64 to the right side. So I'm going to subtract 64. And when I do that, I get 80. Again, all ellipses and hyperbolas are set equal to 1. So I'm going to divide everything by that 80. So 80 and 80. And when I do that, I end up with x squared over 16 minus y minus 2 squared over 5 is equal to 1. And again, I want it equal to 1. So based on this information, I'm going to write down some things that I know. I know that my center will be whatever I'm subtracting from the x coordinate, whatever I'm subtracting from the y. So my center is going to be 0, 2. I'm going to plot that point now. Based on the fact that the x is squared and it is positive, I know that everything's going to happen on a horizontal axis. So I know that my branches are going to open left to right. I know that my a is going to be the square root of 16. So my a is going to be 4. I know my b is going to be the square root of 5. So if I know my a is 4, I'm going to go ahead and find my vertices. So I'm going to add and subtract 4 to the x coordinates of my center. So that's going to be 4, 2, and 4, negative 4, 2. So I'm going to plot those points now. That's a vertice, and that's a vertice. Again, I know the branches are opening left and right, but I'm going to deal with the shape in a second. Let's go ahead and find the foci while I'm doing the calculating part. So foci would be c squared is equal to a squared plus b squared. So c squared is equal to 21. C is equal to the square root of 21. When I go to identify my foci, I'm going to add the square root of 21 to the x coordinate. So I'm going to add it to the 0. So my foci is going to be plus or minus the square root of 21 and then 2. And the square root of 21, I don't know that I did that. 4.6. So that'll be here-ish and here-ish. And I'm just going to do tiny little dots because I don't want them to mess me up. Then I square root of 5. So when I go to make my box, so let's talk about making my box. When I go to make my box, I know that I'm going to go to the left and right, whatever that A was. So I know I'm going to go to the left and the right here and here. And then I have to figure out how tall to make that box. Well, remember the height of that box is going to be the square root, or it's going to be b, which is the square root of 5. So square root of 5. So the square root of 5 as a decimal, because I kind of need the decimal of the graph, the square root of 5 as a decimal is 2.2. So on my graph, I'm going to go up 2.2, and I'm going to go down 2.2, and I'm going to put a little dot. Now remember, those dots are not part of my graph at all. They're just helping me make that box. So now I'm making my box. I'm using those. So here's another line of my box. Here's another line of my box. Now those boxes will help me make my asymptotes. So remember, to do an asymptote, you're going to go from corner of the box through the center to the other corner of the box. And that's going to be one asymptote, other asymptote, corner of the box to corner of the box through the center. So there's my other asymptotes. This is where people tend to make mistakes. Remember that your vertices are going on the x-axis. So the only vertices are these two here. These 2 points here are phantom points. They're not part of the graph at all. So I'm going to go from my vertice and approach my asymptote, and that's going to tell me how wide those branches are. And I think that is everything I have to do for that one. So now I'm moving on to number 4. Number 4 says use asymptotes to find the standard equation of a hyperbola. So I have this graph here in case I need it. I might need it, I might not, but I'm going to plot what I know. So I know that I have vertices at 8, -2. So 8, -2, and then I have another vertex at 8, 8. So based on that information, I know that my center is going to be the midpoint of those two. So my center is going to be 8, 3. So I'm going to go ahead and plot that center now. So there's my center. I know because I have those vertices up and down, I know that, again, I'm not actually having to graph this. I know that my hyperbola is going to open up and down, which tells me that the y-coordinate is going to come first. The y-coordinate is going to be positive. So I am going to do y minus 3 squared minus x minus 8 squared. So I have that much, and then always equal to 1. I know that the distance between my center and my vertice is 1, 2, 3, 4, 5 units. So I know that my A is 5, so I know I'm going to put 25 here. So that's what I know just based on the vertices being at 8, -2 and 8, 8. Now I'm going to use the second part of the information, which tells me that the asymptotes are -7 plus 5/4 x and 13 minus 5/4 x. So I see that my slope, and I really only care about the slope, is this 5/4 or this -5/4. So when I go to make the boxes here, if I want to make the boxes, and I'll do them, I know that this would be the height of the box. I have no idea how wide the boxes are, and I'm going to figure that out in a second. I do know to find the slope between this line is I'm going to go up 5. So I know my slope is 5. My rise of my slope is 5. And in this equation, they told me this. We said the slope was equal to 5/4. So the slope is equal to 5/4. I just said to do this, my rise is going to be 5. So right now, so in this particular case, this 5 is my A. This run would be my B. So I'm going to say 5/4 is equal to 5 over my B, which tells me pretty easily that my B is 4. If I had to cross multiply and solve, I would cross multiply and solve. So my B is 4, which means I'm going to put a 16 here. And then it just wants the standard form of the equation. So there it is. I don't have to finish the graph. I don't have to find the foci. And that's it. The next one, there are 3 listening stations located at 4400, 0, 4400, 1100, -4400, 0. So I'm going to plot those, just rough plotting. So my first station is at 4400. So 4400, 0. The second one is at 4400, 1100. So it's straight up. And then the last one is -4400, 0. So those are my 3 listening stations. This is my first one, second, third. Okay. If the last two, if the last 2 stations detect an explosion 1 second and 5 seconds after the first respectively, determine the coordinates of the explosion, assume that the coordinate system is measured in feet and that the sound travels 1100 feet per second. So what that's telling me is since sound traveling 1100 feet per second, and there's a 1 second difference between this station hearing it and then a second later this station hears it, that tells me something. That tells me, first of all, it's closer to this station because I hear it first. Then it tells me since it's 1100, since it's exactly 1 second and 1 second is 1100 square feet, that tells me that my explosion is directly below those 3 stations. So those 3 stations are going to have to all lie in a vertical line. So this is my, this red dot is going to be my explosion. So that's my explosion. Okay, I don't know anything else really. I do know that I am going to sketch 2 hyperbolas, and I'm going to do it in such a way that these 2 points, because I need that information from those 2 points, I'm going to make those the foci. And the reason why I'm going to make those the foci is, if you remember from the very beginning, D2 minus D1, where that's the distance from a point on the graph, is equal to a constant. So I'm going to sketch this in such a way, and I don't know where that point lies, so I'm going to do this, but the explosion will be on this point, on this branch somewhere. And then I'm going to have this here, so that negative 4400 0 and positive 4400 0 are my foci. I'm going to, and since they're my foci, that means my center has to be 0 0, because that's an equal distance from both of them. That's the midpoint of the negative 4400 and positive 4400. So before I do those, but let's talk about this first. So if this is my center 0 0, the distance between my center and my foci is my C. So my C is 4400. It's the distance between my center and my foci. Then I'm going to call this D2 because it's larger. I'm going to call this D1 because it's smaller. So when I heard this explosion, I heard the explosion, and when I heard it, I realized that it took 5 seconds longer. So when I did this, I made, so let's just have, okay, so I know that's D2, D1. Okay, let me do it this way then. So if I have this point here, that's A. That's A. So if I take the constant, and I can take any number, and if I do this, if I take this point here, let's take this vertice. Let's say this one is D1, and then from here to here would be D2. So D2 minus D1 is equal to, well, D1 is just A. D2 is going to be 2A. So I'm going to explain it differently because I didn't like where I was going with that one. So I'm going to, so disregard everything I said. So I have this. So we know the distance from, so if I take this point here and I want to find what it's, so if I take the distance from this foci to this point, I'm going to call that D1. If I take the distance from this point over to this point, I'm going to call that D2. Now graphically, what is this first D1? Well, this D1 is going to be the distance, is going to be this C, because this is C, right? So C, no, I'm doing D1. No, I'm doing D1, sorry. This D1 is going to be this C minus the distance from the center to the foci to the vertice A, so that's D1. D2 is going to be the distance from the point to the center, which is A, plus the distance from the center to the other foci, which is C. So when I take D2 minus D1, I'm going to take A plus C minus C minus A, and this is equal to my constant. So I'm going to have, it's a C. I'll make it a capital C, not to confuse with that C. So when I do that, I distribute the negative sign. So I'm going to end up with my constant is equal to 2A. So that's what my constant is equal to. And this is little c. So that's little c. So what is my constant difference? Well, they told me. I have this point here that when I heard the explosion, it was from here to here and here to here. This heard the explosion, and then 5 seconds later, this guy heard the explosion. So the difference between D2 and D1, because of that, is going to be that 5,500, because it's 5 seconds, 1,100 feet per second. So that means 2A is equal to 5,500, which means 1A is equal to 2,750. So what do I have so far? Well, I have x squared, because I'm opening left and right, x squared over my a squared, which will be that 2750 squared, minus y squared over b squared is equal to 1. Well, I don't know b squared, but I do know c. So to find b squared, I'm going to say c squared is equal to a squared plus b squared. So taking that 4,400 and squaring it is equal to that 2750 and squaring it plus b squared. When I do all that, I'm just going to leave b squared as it is. I'm not going to bother taking the square root. I get b squared to equal 11797,500. So when I do that, so that's great. I have b squared. So now I'm going to rewrite this as x squared over, and then I went ahead and squared that 2750, just because I thought that would help me out later on in life. So there's my equation. Now it wants the whole thing, so great, good for me, I have the equation, but that doesn't answer the question. It wants the coordinates based on this coordinate system. It wants to know exactly where this explosion is so I can send the paramedics and the fire station and everybody there to go help them. So to do that, what I'm going to have to do is I have 3 unknowns right now. Well, I have 2 unknowns. I have x squared and y squared. But I do know one of them. Remember when we said this, we said it was a direct vertical line, and it had to be a direct vertical line to make this exactly 1 second later. So that means that this x coordinate is going to be 4,400, and I'm looking for the y coordinate. So I'm going to go ahead and put that 4,400 in for x and put everything else in. And then I really don't think I need to tell you how to solve this. You can solve it. And when I solve this, I end up getting, when I take the square root, y has a choice of being plus or minus 4,290. Well, if I go back up to my graph, since it's in the 4th quadrant, my y has to be negative. So the ordered pair for this is going to be 4,400 and then negative 4,290. And that's the coordinate of the explosion. I know I went over that half fast, but I hope that helps. The last thing is general equations of conics. So when I'm looking at conics, how do I determine what shape I'm going to get before I even pick up my pencil to start graphing? So if I write it where I have the 2 things that are squared first, and you will notice that we are skipping B, and the letter B is not represented because the B comes into play when I have a B is a coefficient of my XY term. And when I have an XY term, that's a whole new can of problems because I'm rotating it, and we'll get there, but not today. So these rules still apply though even when you have a middle term like that. So A and C are my coefficients of my two squared terms. So that's all I'm really going to look at. I really don't care about the rest of the equation. I don't. I really don't. So what I'm going to do is I'm looking at A squared. I'm looking at the A and the C. If those two are equal, then it's a circle. If A or C, if either one of them is equal to 0, but not both, if either A is equal to 0 or B, so you only have an x squared or you only have a y squared, and you don't have two things that are squared, then you're going to have a parabola. If they are both equal to 0, then you don't have anything squared, and you're left with a line. So that's not fun. All right. If A and C, if I multiply A and C, and they have like signs, so they're either both positive or they're both negative, then it's an ellipse. And when they're both negative, that means I have a negative over there, which you can't see where I'm pointing to. I end up dividing by a negative and it ends up being positive, so life is still good. So if the signs are the same, and so I think of it that way, if the signs are the same, then I have an ellipse. If the signs are different, so I have one's positive and one's negative, then it's a hyperbola. So when I go to do these, when I'm looking at this, I'm literally ignoring the rest of the equation. Could care less about that. I mean, it helps me graph and everything like that. It's important, but not to identify, not to classify. I have an x squared and I have a y squared. So I have two things that are squared. That eliminates it being a parabola. When I look at this, I see that one is positive and one is negative. So as soon as one is positive, one is negative, it is a hyperbola. So the next one, I have x squared and I have y squared. Again, not caring about the rest. Sorry. They both are positive, so I know it's either going to be a circle or it's going to be an ellipse. Since they both have coefficients of 1, that makes it a circle. Looking at C, I have x squared. And I search and I search and I search and I can't find anything else squared because, again, don't care if it's not squared. I only have one thing squared. That makes it a parabola. And I don't care if this coefficient here is positive or negative. Does not matter. That just tells me if it opens up, down, left, or right. The last one, I have 2x squared, 3y squared. So they're both positive. So I know it's going to be either a circle or an ellipse, but since the coefficients are different, it becomes an ellipse. And those are really that simple, that quick, and that's all you have to do. Okay, I hope this helps. There's the homework that's on Blackboard, and I will see you next time in class.